Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello dear students, I'm Mr. Muhammad Sultan and this is my channel for physics. Today inshallah we will finish chapter 2 in unit 1 for the second year secondary. Okay, I have a question now. What will happen if a light ray passes through a triangular prism? What will happen if a light ray passes through a triangular prism? What if this light ray is white light? And what if this prism is a thin prism? All of these things, inshallah, we will know today. So pay attention, subscribe, and if you have any question, please write it in the comment, and inshallah, I will answer them. Okay, let's start. You know that light travels in straight lines. Good. So if I have here a light ray, it will pass like this. Light ray moves like this. Yes. What if I put here a triangular prism in its path? What if I put a triangular prism in its path? What will happen? Okay, teacher, we studied that if a light ray passes from a medium to another medium, from air to another medium, it refracts. Of course, yes. So it will not move in this direction. It will not travel in this direction. Okay, where does it travel? To know where it travels, I will draw here a normal to this. It must be drawn. Please, if you are working on refraction, you have to draw the normal, which is perpendicular to the surface. So this surface here, I will draw here a normal to it, which is perpendicular to it, like this, a normal, right? And it makes here a right angle. Good. And of course, this will be the angle of incidence. For example, it will be here the angle of incidence. We call it phi. Tamam. And this ray will refract toward the normal or away from the normal. It moves from air to any other. If light rays move from air to any other medium, they refract toward the normal. Why? Because light in air is faster than any medium. Okay? In air is faster than any medium. This means it is faster here, so the angle is larger here. It is slower here, this means the angle will be smaller. This ray will be like this. This ray will be, for example, this is the normal. It will refract toward the normal. This is the angle of refraction. We call it theta. Look, the light ray will move, was moving like this, was traveling like this. Now it becomes like this. Tamam. So it will not be in this direction. Good. Now this light ray passes from air to this medium of the prism. It refracts toward the normal. Here again it will move from this medium to air again, so it will refract. Yes. How does it refract? Again, I have to draw a normal. Yes. To draw a normal here, it makes an angle 90 and normal is like this. It makes an angle here 90. Then, what about this ray? When will it travel? It will refract away from the normal. Why? Because it's here faster, so the angle is larger. To refract away from the normal. Oh, teacher, look, and instead of traveling like this, because we put here a triangular prism, it deviates from its original path. It deviates. So this lesson, inshallah, or this part is called deviation of light in the triangular prism. The deviation of light, okay, in the triangular prism. تمام. This prism has an apex here, apex, which is angle here. The apex angle is A, for example. طيب, can we know how much the light deviates from its path or from its original path? Of course, yes. If we measure the angle between the original path or the original ray, the normal ray, the ray itself, and the emergent ray, if we measure the angle between the emergent ray and the original ray, we can get the angle of deviation. How to get it? I make here extension to this. And now this is the angle of deviation, we call it alpha. The angle here is alpha. Teacher, we said here this is phi, the angle of incidence, theta, the angle of refraction. What about these angles? These angles will be phi and theta. So we can put here 1, 2, 2. Angle of incidence, refraction, incidence, refraction. Tamam, teacher. Can we calculate this angle? Can we know how much this angle is? Yes. How? Look here. If I say that this angle is called 1, this angle is called 2, and we can put here a symbol A, or sorry, have here A, so we can put here B, and we can put here C, and here D, for example, and we can put here E. Tamam. Look here. I want to get the angle of deviation. Tamam, teacher. The angle of deviation here is an external angle. Look at this triangle, EBC. EBC. This triangle, this angle is external. This angle is external. So alpha equals the sum of these two angles. Alpha equals the sum of angle A plus angle 1, sorry, and angle 2. Tamam. And we don't know them. Tamam. Look here. Alpha, phi 1, look at phi 1, it is this one. Phi 1 equals theta 1 plus angle 1. Phi 1 equals angle 1 plus theta 1. Tamam. Theta 2, the same thing, equals phi 2 plus 2. Tamam. Good. So if I want to get 1 only, I want to substitute it here. 1 here equals the angle 1 equals phi 1 minus theta 1. Look at this. From this equation, angle 1 equals phi 1 minus theta 1. And from this equation, angle 2, the angle 2 here equals theta 2 minus phi 2. You will not be required, you will not be asked to calculate all of these things, but I want you to know how to get the angles. طيب. So I can say here alpha equals 1, which is phi 1 minus theta 1, phi 1 minus theta 1, plus 2, which is theta 2 minus phi 2. Tamam. So alpha here equals, if I collect them together, I will get the pluses together, so it will be phi 1 plus theta 1 minus theta 1 minus phi 2. I can take here minus common factor, so I will change this sign. If you take minus common factor, you must change the sign. Look at this. Negative times positive is negative, and negative times positive is negative. طيب, we can put here, this is number 1. طيب, we still not know these angles. These angles are inside here, we cannot get them. طيب, how to get them? Just wait. Yes, we can know the angle of incidence, we can get the angle of emergence. This is called the angle of emergence. Okay. This is the angle of emergence. We can call it, this is the angle of refraction here. We call it the angle of emergence because here we can see the light again. That's why it's called angle of emergence. When we see it again, this is called the angle of emergence. Look here. Look at this triangle. Look here. The sum of these three angles is 180. The sum of these three angles is 180. Tamam. And in this big shape, yeah, you can say here D plus theta 1 plus phi 2 equal 180, the angle D. Tamam. طيب, in this big shape, in this shape here, this angle is 90 and this angle is 90. Tamam. So the sum of these two angles, look at this shape يا شباب, A, B, D, C. A, B, D, C. This shape has this angle 90 and this angle is also 90. So the sum of these two angles is 180 and the sum of these four angles is 360. These two are 180, so these two must be also 180. So here I can say that the angle D plus angle A equals 180. D plus these are 180 and D plus this is also 180. What does it mean? This means angle A, which is the apex angle, equals phi theta 1 plus phi 2. This is equation number 2. From this one, I can substitute, look at this, theta 1 plus phi 2, theta 1 plus phi 2. So I can substitute this by only A. So it will be alpha here, the final thing, alpha equals phi 1 plus theta 2 minus theta 1 plus phi 2, excellent, minus A. So this is how to calculate the angle of deviation. The angle of deviation. The angle between the extension of emergent ray and the extension of incident ray. This ray must travel like this. But because of this prism, it deviates, it changes its direction. Okay, so this, and instead of moving like this, sorry, and instead of moving like this, it deviates from its original direction. It deviates from its original direction. Okay, so the angle between the extension of the emergent ray and the extension of the incident ray is called the angle of deviation. We can calculate it from this equation. So if we know the angle of incidence and the angle of emergence, and the apex angle, we can get the angle of deviation. And I want you to use this. Look here. A equal the insiders. A equal the insiders. A equal the insiders. Alpha equal the outsiders minus the insiders. Alpha equals the outsiders minus the insiders, or you can say that minus A. This is the most needed, and this one. You can focus on these two. This one and this one. طيب. Look here. Alpha, the angle of deviation depends on the angle of incidence. How does it depend? Does it increase or decrease? If the angle of incidence increases, what happens to the angle of deviation? Listen to this. By increasing the angle of incidence, the angle of deviation decreases. Okay, till it reaches the minimum deviation. After that, by increasing the angle of incidence again, this angle of deviation increases again. Look here, for example, if I have here a relation between the angle of incidence and the angle of deviation. By increasing the angle of incidence, the angle of deviation decreases till it reaches the minimum point or the minimum deviation. After that, by increasing the angle of incidence again, the angle of deviation increases again. So look at this. By increasing the angle of incidence, the angle of deviation decreases till it reaches the minimum deviation. And after that, by increasing the angle of incidence, the angle of deviation increases again. So it decreases here, and after that it increases. This point is called the minimum deviation. Okay, and inshallah we will see how to calculate it. Now everything is clear. Let's move to talk about the minimum deviation. As we said here, minimum deviation is called, the angle of deviation is called alpha. The minimum deviation is called alpha naught. Alpha naught. Tamam? This alpha naught is called the minimum angle of deviation. This is called the minimum angle of deviation. طيب, look here. At minimum deviation, what happens? When these conditions are at minimum deviation, do we have anything to change here? Of course, yes. At minimum deviation, the angle of incidence, look here, the angle of incidence will be equal to the angle of emergence, and we will call them phi naught. Alpha naught, phi naught. Tamam. The angle of refraction here will be equal to the angle of incidence here, and we will call them theta naught. So these two angles will be equal and we call them phi naught. These angles will be equal and we'll call them theta naught. طيب. Again, if we move back to the two equations I told you to remember, these two equations were A equals theta 1 plus phi 2. And we said here, these two will be equal and have this. So from this we can say that A equals theta naught plus theta naught, يعني A equals 2 theta naught. تمام. This is A and this is theta naught. So from this, theta naught equals A over 2. 2 theta naught equals A. This means theta naught equals A divided by 2. This is number one here. The second thing we said is alpha equals phi 1 plus theta 2 minus A. صح. If this is the minimum deviation, this will be phi naught and this also will be phi naught. تمام. So I will say here alpha naught equals 2 phi naught minus A. تمام. This A can alpha naught plus A. A is moved here. Now alpha naught equals, sorry, phi naught equals alpha naught plus A over 2. Why am I calculating all of these things? This, if I want to get the refractive index of the material here, if this is air, if I want to get the refractive index of the material of the prism, look here, n equals sine this angle. When we talk about minimum deviation, this angle is called phi naught over sine the angle of refraction, which is theta naught. Phi naught is here. So N equals sine phi naught is alpha naught plus A over 2. Theta naught is here. So sine theta naught means sine A over 2. Don't cancel 2 with 2. These are in a bracket here for sine, and these are here in the bracket for sine. Don't cancel anything. Here, don't cancel anything because these are one angle and these are one angle. So please. طيب, this is how to get the refractive index of the material of the prism if I know the minimum angle of deviation and the apex. I can get the absolute refractive index without knowing all of these things. Only if I know the angle of the minimum deviation and the apex, خلاص, I can get the absolute refractive index of the material of the prism.